Welcome. My name is Min from Stainless. We are quite excited to be co-hosting Agent Experience Night with Keycard this evening. For those of you not familiar with Stainless, we generate SDKs, docs, and MCP servers for customers like OpenAI, Cloudflare, Anthropic, and Google DeepMind, along with a bunch of more API companies. The run of the show tonight will be as follows. Each presenter will give a demo for about 10 to 15 minutes, which will then be followed by Q&A for another 5 to 10 minutes. We have some exciting stuff lined up for everyone this evening, and this will go on for about an hour and a half. After the demos conclude, we do have food and drinks in the back, so please do feel free to stick around, network, chat, and have a good time. So thanks again, everyone, for coming out. And for the first demo, we will have Dominik from OpenAI presenting.
Hi, I'm Dom. I work on developer experience at OpenAI. Specifically, I work a lot on Codex. How many of you have tried Codex before? All right, cool. Most of you. Hopefully, I can inspire the rest of you to play around with it as well, but also show you some fun stuff. One of the first things that sort of like comes up when I ask about Codex, it's sort of like which codex, like OpenAI released like a million different things that are called Codex. For us, it's really sort of like all seen as like the same codex. So regardless of whether you're using Codex in the CLI or in an IDE extension or through things like the Codex app or even third-party apps like Codex Monitor or T3 Code or things like that, it all actually is like the same Codex agent under the hood. And the way that works is we're actually like the Codex agent is open source. So you can look behind the scenes on how all of these things work, but all of them use what we call app server under the hood. So the Codex agent actually can be run in this app server mode, where if you have the Codex CLI installed, you just run Codex app-server, and it starts up a JSON RPC protocol that can either run by a WebRTC or just like a traditional sort of standard in, standard out process. And then all of these different interfaces can actually tap into that. So the Codex app actually runs on that same app server as like the JetBrains integration or, third-party apps like Codex Monitor. And that means we can kind of integrate Codex anywhere. Meaning you can get the same agent regardless of like what interface you're actually working on. You have a really extensive protocol. So this is not sort of like on the same level as like MCP, for example, where like it's designed specifically for like another agent to control, even though you could use that, but it's really sort of the same protocol that we need to use for the app. So like there's everything from like starting new threads and being able to pull that context, but then also even things like, listing all of the skills or plugins that are installed on a device. It also comes with sign in with ChatGPT. So if you're building an app where you want people to like sign in and have Codex used through their own subscription, you can actually like use that sign in with ChatGPT flow through that Codex app server. And so I don't know how many of you saw that, but like one of the ways that I was trying to put Codex anywhere is I actually published on Monday a plugin that allows you to use Codex inside Claude Code. So if you want to use Codex to like run code reviews or other things, you can install that plugin and then run like /Codex review or Codex rescue to like delegate a task to Codex. And that uses the same app server behind the scenes as well. So it's again that same agent. But if we're talking about really anywhere, sort of the obvious thing we got to talk about is Doom. Because that's sort of the notorious thing of like, can I put Doom anywhere? In fact, I put Doom into the Codex app so that you could just play Codex. You could play Doom while Codex was doing tasks and only play it while it was doing tasks. So you have to give it harder tasks to play longer. But since I already did that for today, I thought it would be fun to do it the other way around and actually put Codex into Doom. And that's where I'm going to sit down and jump into my demo here. Let me find, there we go. So I'm in a Codex app here because like Codex built this entire thing. I didn't do anything. This is like 200 million tokens across a couple of hours in one single thread. We can go through that later. But for now, I'm just going to start this up. This is actual Doom. If I turn on my speaker, you can hear the sounds. So this is Doom. If you've ever played Doom, you just walk around, you can fight enemies. But I actually put Codex in here. So this is it actually modified the actual video game and the renderer. So this is in the actual in the actual Doom video game. And so if I go here and interact with it, I have a Codex terminal. The graphics are intentionally shitty because they're, again, in the actual video game. This is like C code that is running that Codex wrote. And so to prove it, I'm going to switch to the Spark model here. I can go say hello. You can see Codex is responding. And like the nice thing now is that I have both because it's Codex. It has access to my file system. So like, what folder are you in? Is going to give me here like the folder that the actual app is running in. But I can also do things like you can see down there, I have like 0% armor. So give me 100% armor and also the best gun available with all ammo. And so now we can see here it's going to actually use some custom tools that I exposed through it, again, through that app server protocol. And so now I should have, you can see 100% armor. And if I go out of the terminal again, there we go. I have now the BFG, which is sort of the best. That is not, for context, that is not my device. Cool. But yeah, like this is, it's like the full Doom game. So this was really just sort of like a silly way of me like playing around with like, where can you put Codex? To give you an idea of how this works, again, Codex did all of this for me. I didn't do really anything, so I asked it to create a diagram for me. But it's essentially an Electron app that runs a that runs a Doom engine from Cloudflare, or rather a fork of it, that runs Doom in WASM, so WebAssembly, and then it modified it further. And so whenever I ask it to do something, it goes through first to actually like do the turn in the app server, and then it renders everything back into the actual video game. So the video game renders the terminal, and has all of that interaction mechanism, and then like all of the tasks run on the actual Codex app server, and Electron kind of like works as like the glue in between that. But because of that, like one of the tasks that took the longest was actually this, which if I scroll up here, I wanted the Codex logo to actually be in there. So it had to like go and modify the game. And it worked for like an hour on like figuring out how to create its own graphics inside the video game and modify it, which was also highly distracting because Codex kept playing the video game in the background. And so I kept hearing gunshots go off in the background while I was like walking throughout the house. But yeah, like you can see here, it like went and took screenshots, and it tried to approach it from like, this was the final one. But if I go in here, you can see it was like trying to see like, oh, is this a good wall to place it? And like, why is the pattern not there? And like, kept going through a couple of different iterations here until it eventually got there. Inspected like different walls, messed up the logo, and then kind of kept iterating on it until it got there. So that's a long winding story of try out the Codex app server. It's fully open source. You can both learn how it's being built of like as an agent, if you want to learn how we build the Codex agent, but you can also put it into any application if you want to have like a really easy way of adding a very powerful agent into your own application. Thank you.
Awesome. Any folks with questions that I can pass the microphone to?
So app server, very cool. I'm curious, like sitting from OpenAI Codex's perspective, do you think many things we've seen in the agent space have moved towards pretty quick standardization, like protocol standardization? We had agent files, skills, whatever. What do you think happens here? Do you think this becomes like something that every one of you, when all of the our agent harnesses adopts and makes standard, or is this something that's just very special for Codex to build on?
I don't know if necessarily like that per se is going to become a standard. I think one of the things that it does help with is sort of, I think what we've seen is um, the like Codex, for example, when we release like GPT 5.4 or other models, like we give people a lot of prompt guidance on how they can actually get the most out of the model and what tools it was trained on. But then you're kind of getting into the state where you're like rebuilding those same tools versus like being able to just like leverage that same agent off the shelf basically, and being able to rely on that and like not having to spend a lot of time trying to like wrap your head around how those things fit together. So like especially for a lot of like the coding tools, this is like an easier way of you to like focus on the user experience or like interop that you want to have rather than like having to also build like a full-on agent for every kind of model basically. So yeah, the question, just to repeat, was how do you come up with sort of like new things to build? Because like at this point, like Codex and Cloud Code and things can like one shot a lot of things. For me, that's sort of the fun part of I've become a developer because it allowed me to turn my ideas into reality. And so now I get to, like turn these ideas into reality much faster. So I think like the big thing is more to build that muscle of like quickly turning ideas into like proof of concept and just like see if it works and then like carry on. Like for this, I had no idea if this was gonna work. I was like, I feel like it's gonna work, but like I also didn't have enough time like to try to crank this out. It did most of this like entirely on its own. So like I had it also like try to build another video game just as sort of like a backup solution. So I don't know if I have like a concrete idea other than like, keep your eyes open unless like the more you get sort of used to just talking to the model, talking to the agent and like trying to brainstorm ideas together.
So in the thing that actually made the demo, I was kind of impressed by the fact that the agent was able to like move around in the game and also like take screenshots. I think
Yep.
I'm assuming. How does that work? Like, does that just work out of the box? Like, I should.
Yeah, so I mean like one of the like in this case it just used Playwright to figure things out. And like sometimes I use like a bit of a nudge of like go use Playwright to test it. For example, in this case, we also have like a plugin called like game development, which is helpful because it like gives like just like a skill and a couple of like nudges around Playwright to um help the model like plan the steps of like what it wants to do in the video game and like do it more repetitively. But like it figured most of those things out by itself. Like I would just like be like, this doesn't look right, and it's like, let me check. And like I had this one time where I was building an iOS app and it built the first iOS app. I like opened it in the simulator and it looked weird, and I was like, this like doesn't look right. Like something is wrong. I'm not an iOS developer. So I'm like, this doesn't look right. And I sent it a screenshot and I was like, it should look completely different. And I kicked off a task. I went to a meeting. I came back and it worked for an hour, and it had like figured out how to control the simulator by itself and like reload the app, try out different things. And like it got to a point where it both fixed that layout issue, but then it also was like, well, now the app looks good. So I can like start interacting with it and like verify that every feature works and like fixed all of the other features that it was doing along the way. So like my tip would be like, just ask it to do things, and then you can, after a while, like if it takes too long for it to like redo those things, or if you want to do it in future conversations, just ask it to turn it into a skill after the fact. But that's normally sort of like the easiest way.
Hi. So what's your view on MCP versus skills?
I don't think they're like it's very interesting. I just did a talk that was related to this last week. Like I don't think they're like contradicting each other. So like for example, like with Codex plugins, actually like a lot of the plugins contain an MCP. I think the big thing is like one benefit that MCP has is that it actually has like a standardized way of authentication, which I think is like highly undervalued for people from people in like the grander scheme, because like a CLI tool that like uses an API key works for you if you're like a solo dev messing around with stuff. But like, for example, if you're in an enterprise and like, someone goes to the IT admin or security and is like, hey, can I have an API key to like every platform that we have? Like, they're not going to feel comfortable doing that, versus like if you have like OAuth 2.1 in like a very standardized way. Now, there is some CLIs that do OAuth and stuff, but like it significantly limits sort of like a lot of them don't do like they have to be first party, because otherwise they're going to become dodgy and stuff like that. So I think hosted MCPs are like still incredibly valuable, especially for those like permission aspects. Local MCPs, I would say, like are easier to swap out with like just plain CLIs and like combining them with skills. But even a skill around an MCP can be helpful, because like it helps bundle, like a MCP server will send you very generic instructions, and then a skill can help you package that in a much more like use case centric version. Thank you.
Next, we'll have Christina from Google.
Okay. Hi, everyone. My name is Christina, and I'm a developer advocate at Google. Today, I will be talking about building multi-agent systems with the Google ADK, and we will be talking about Dungeons and Dragons as well. So a brief primer to start. The Google Agent Development Kit, the ADK, makes agent development feel really easy. We just launched it in Go and Java, so you can code it in whichever language you like. We also support JavaScript, TypeScript, and Python, of course. It is also open source, so anything I show you today, you can just go on GitHub and check it out yourself and start using it for free. So for those of you who do not know what Dungeons and Dragons is, it is a role-playing game that you play with your friends in real life. You all get together, you all make your own characters, and you go on a magic epic adventure. But you might notice there is a robot at the top of the table who looks a bit different, and that's because he is the Dungeon Master. And the Dungeon Master has a very hard job, which is to orchestrate the entire adventure. He has to remember all the characters' names. He has to remember what he said as an NPC 6 months ago. He has to remember all the different kinds of enemies that you can fight. So as a result, the Dungeon Master has a very difficult job, and it also kind of sucks because he can't even like participate in the campaign, which is why I was like, oh, I should just make an agentic Dungeon Master to do it, and then all my friends can participate. So you might be asking me, well, why can't we just use Gemini to be a Dungeon Master? Why do I need to build an agent for this? So if Gemini is the big robot on the left, then the multi-agent system is the 3 small robots in the trench coat on the right. And that is because the monolithic LLM, you may have noticed, if you keep talking to it for a very long time, it's going to start hallucinating and forgetting important context, which is really bad for a Dungeon Master, especially if, the NPC that helped you in the beginning of your journey actually turned out to be, the evil dragon lord that you're supposed to fight at the end. So yeah, that's no good. So that is why we need a multi-agent orchestration system to kind of help us remember all those facts. And each of these tiny robots has a specific job that, when added together, performs the same as the big robot, but better. So before we get started building, I wanted to discuss the 3 different sub-agents that ADK provides you out of the box that you can use to help build out your agentic system. We have sequential agents, which executes a workflow in a specific order. So this is really good for things like character creation, which has a very strict order, like character name, character class, hair color, etc. Next, we have a loop agent, which iterates a task repeatedly until a certain condition is met. And this is good, for example, if your team is fighting 500 worms and the Dungeon Master has to update the status of all 500 worms. That would be a really good use case for that. And parallel agents execute things concurrently, so that is great for things like opening treasure chests in the treasure room. So this is kind of how I thought about making my D&D Dungeon Master. There is the root Dungeon Master, which is the root agent orchestrating the entire campaign. We're going to have some specialized sub-agents, like the merchant agent, which is an NPC that handles, selling items, buying items, a vision artist to help bring our campaign to life. And then these sub-agents will also have access to some tools at the end, which you will also be able to see. Speaking of specialized tools, ADK also comes out of the box with some really cool tools. So for example, Google Search is one that comes out of the box of ADK, so you don't have to write any extra code to get Google Search working. And I tested this out. I made an NPC sub-agent that sold newspapers in my town square, and I had them Google search the top news from today. And then I translated to medieval speak. So it said things like, the new Oracle Gemini has released a new open source model called Gemma 4 today, by the way. And then we can also write our own tools with custom Python logic. So for example, dice rolling, and we will be seeing some of that soon. So I talked a lot about slaying dragons and fighting, worms, but a lot of these things can also be translated to real life use cases like code reviews, routing things to customer service. So let's get started building. So once you open up ADK, this is the visual builder that you will see. And I created this agent here. To the right, we have a helpful AI assistant, and you can talk to it and it will actually build the whole thing out for you. But I kind of want to show you how it works beneath the hood today, so I'm just going to close that. And if we click on the root agent, this is what you'll see out of the box. It'll tell you what model we're using. We can do 2.5 Flash or 2.5 Pro, and the instructions. So if we just press save and talk to it, this is what the debugging panel looks like, and we can talk to our agent like this, which is great, but that is not what we want. We want a dungeon master. So here I will be writing, you are a Dungeons and Dragons dungeon master for 5e in charge of a compelling campaign. Your adventurer woke up and is in a town square, and there is a dragon's lair to the right. So if we press save and talk to it again, I don't know how easily you can see this, but you can see that it says, hello there, adventurer, welcome to the world of Dungeons and Dragons. And this is like pretty good for a dungeon master, but we can do better. And I want to show you what this kind of looks like on the back end. So I have it running here. And you can see that the ADK, although we built it visually and edited it in the web designer, it actually created the YAML file here on the back end, which is very simple, and it saved our instructions too. Okay, well, let's go back to coding. And then we go back to builder mode. And one of the most important things a dungeon master has to do is roll a dice. And this dice rolling tool is good for determining things like how lucky you are, how much damage you do to a monster, how much HP you have, stuff like that. So we're going to start off by adding our first tool call to this D&D Dungeon Master, and we will do it here. And I just kind of want to show you, like, here are the built-in tools that you can just add without coding anything else. Like there's the Google search I mentioned, and there's a bunch of other ones. That's not what we're gonna be using today, though. We're gonna be making our own tool, and we're just gonna call it roll dice. And I'm gonna go back to the back end, and we actually have to create a new file here, and I call it tools.py, and this is where we're going to be putting our dice rolling function. Because this is a pretty short demo, I am not going to write a dice rolling function from scratch, but I do have one ready here to copy and paste to show you guys. So we're just gonna copy and paste that in here, and this is our dice rolling function. And here we have what we're gonna tell our dungeon master how to use their new dice rolling function. So we go back, we actually have to edit the instruction and tell him, hey, you now have a new dice rolling tool. When you roll, whenever the player tries something really risky, like fighting, stealing, investigating something, you must call roll dice. And then it tells you, tells them how to use it. So we save. We go back, just double check it updated here, and it did update. So we're going to rerun our app over here to pull our new tool. We go here, let's try again. Let's type hello. Great. Now I'm going to say I investigate the dragon's cave, and hopefully this should trigger a dice roll. And it did successfully trigger a dice roll. And what's cool about the visual builder is that you can actually click into this function call and kind of debug it straight from your web browser. I'm just running this all in Chrome, by the way. So you can look at the request here and look at the response here as well, in case you need to debug it, which I think is really cool. So you can see we rolled a 10, which is perfectly average. So I do a pretty okay job of investigating. I actually reveal nothing immediately obvious from the entrance. What do you do? So we have our first tool call, but we can do better. I want to make a sub-agent now. So the first sub-agent we're going to make is going to be our image creation agent, because I want to see what my adventure looks like as I go throughout my D&D adventure. So I'm going to make a sequential sub-agent. I'm going to call this image generator. And in my sequential agent, I'm going to add 2 LLM agents here. And the first one, I'm going to call it prompt improver. So although we could just toss whatever our Dungeon Master said straight into the image gen tool, I actually want all my images to be super cute, and I want it to be like watercolory. So I made a prompt improver to execute that first. So I'm going to say you are a sub-agent that improves a D&D description as an image prompt. You will add details and make sure the image/scene is cute and full of watercolors. Great. So after they're done improving your prompt, they will pass that on to our next sub-agent here, which will do the actual image generation. I'll call it image creator. You are a sub-agent that creates images. Use your create image tool to create an image and then pass it back to the main agent. And that should almost be good, except now we also have to tell our Dungeon Master that it can make images now. So now we have to say, after each turn, make sure you call image generator sub-agent to create an image of the scene. So you can kind of see how this is very modular, how each agent has their own job, and that way the LLM won't get confused. So we click save. Oh wait, no, I actually didn't make the image tool call. Let me add that. Tools, create image. Okay, so now it's all linked together. I'm going to press save. And now we have to go back into our code. And if you investigate the YAML files that our visual builder has made, it has made the image generator, which is a sequential agent class. It goes to the prompt improver first and then goes to the image creator second. And you can see all our instructions that we typed are here for you. Great. Now we have to add a new function to our tools.py, which is our image creation function, which I have also conveniently created already. And we will be hitting nano banana. So here is our image generation prompt, create image. We go back. Wait, I have to restart the app to pull my new create image. We refresh here, and now we try it out, and hopefully we get a nice image from our Dungeon Master. So you can see it transferred to our agent here, and it actually has like a cool visual showing you like the logic as it goes down. And this is our prompt improver agent, which did a pretty good job of improving my prompt. And then it passed it to the image creator agent, which described my scene pretty good. I am pretty happy about this. And now I'm going to try and trigger the dice roll and the image creation in the same turn and see if it can handle that. I want to investigate the dragon's lair now. So it successfully rolls the dice. I got a 16, so hypothetically I should have investigated very, very well. It transfers it to our image generation agent and improves the prompt. And this is my investigation. And that is how I made a D&D Dungeon Master in 10 minutes. Thank you. Does anyone have any questions?
So you had the subagent there with the image generator. Is that like stateful in the sense that like every time you call the subagent, like there's like it knows like the previous runs or anything like that? Is there a way to like make that happen if you wanted to?
Yeah, so the way the 80K handles state is very complicated and it has like a whole bunch of stuff happening in the background. But essentially, the question is, how do the subagents know what's going on? Is that the question? So when the main agent calls the subagents, it gives it a very sanitized version of the data. It doesn't need to know everything. For example, like the merchant NPC subagent, it doesn't need to know what's going on in the campaign. It doesn't need to know about the Dragon's Lair. So when the main agent calls the subagent, it only filters out a very specific context for it so the subagents can do their job properly. But you can also do things like persist a player sheet in the database, for example, and all these different subagents and the main agent can access that persistence layer. So there's a couple different things going on for state.
So under the hood, is this like how's the state that's in the diagram actually represented when you create these tools? Is this like a JSON file? Is it code under the hood? Like what is it? And then when you go to like deploy this thing, how does it get deployed? Like what's the orchestration layer?
Right. So when you add stuff in the UI, it actually lives in the repo that you run this script in. So I'm running it in this folder called Meetup Demo, and every time I click the save button, it updates and adds the YAML files that I did before. So for example, whenever I create a new subagent, it generated a new YAML file for that subagent. And the 80K files are listed here, so you can go through it and see like all the different sessions and discussions you had with all your subagents. But yeah, the visual builder is basically like a more friendly version of just manually adding the YAML files yourself. So it is very convenient to deploy it on Google Cloud. It is like a single line to deploy to a Cloud Run if you're linked up to a Google Cloud project. But because 80K is open source, I'm sure you can deploy it on any function you want. Like this will just work out of the box.
Next up, we will have Andrew from Vercel.
How's it going? I'm Andrew from Vercel. I work on all things, everything, most recently skills and the Vercel plugin. And I'm here to talk to you all about how we built agents without re-engineering the same thing every time. Who here has built agents? Anything? From anything? Good amount of hands. Seems like a lot of you have tried to build agents. It's good. So at Vercel, we are extremely agent-pilled. We probably have at any given point right now like 20 or 30 production-ready agents that do some amount of work for any function, data, marketing, engineering, design, sales even, GTM. And it kind of started around 6 months ago when I built this agent called D0. We have this kind of popular product called V0. It's a vibe coding tool. And I built this thing called D0. That's a data science AI tool. And before I get into that, I just want to say that we at Vercel love to build a lot of the primitives to make it easy to build new agentic experiences. So we have a bunch of these packages and a bunch of these different ways to compose new experiences. MPMI AI, single line swap out to use any AI model. MPMI chat, that gets you access to Telegram, WhatsApp, Discord, Slack. Your agent can communicate across all these different surfaces. We have workflows if you want to run long-running jobs with retries and callbacks and webhooks. We have Sandbox to securely run your agents and to run untrusted code as well. And of course, we have MPX skills if you want to load your agent with the best skills to make it more accurate. And so this whole thing with D0 started because we wanted to do this thing called an agent on every desk. We think just like how computers were sort of this foreign topic maybe 20, 30 years ago, an agent is currently the same way, but eventually we'll have an agent on every desk like we currently have a computer on every desk. And so I went around to every function in Vercel, and I asked them, like, what do you hate about your job? And the best answer I got was the data team. They were kind of new, they were sort of small, lean, and they were just so backed up with indexing new data, with trying to get the new usage all over the place into the right places, as well as fulfilling people's one-off queries, like what's our current ARR, what's the spend currently looking like, how successful is product A, B, C. And so they had to keep on writing new and new queries for the sort of the same stuff over and over again. And so if we could sort of eliminate that part and have them focus on making the data warehouse and the archival better, then everyone's life would be better. And so I started with talking with our VP of data, and we just sort of gave it this very arbitrary example where we just fed it the laziest way possible. We dumped out all of our Snowflake schema, and we asked it a question, and we asked it to write some SQL. And then we would go and run that SQL by hand. And that was a good first pass. It gave us some conviction that even though it didn't get it fully right, it was sort of directionally on the way there. So from this, we were like, okay, we can make this better. This is a good V0, but we can make it better, more accurate, put into more places. And so then we went on to phase 2. This is back in like October. So this was when subagents were the biggest craze. We tried breaking down the concept of building a SQL query and executing it and reporting on it into many different phases. We first did a plan phase that had access to all of the different entities, all of the different join patterns. We had another phase that was dedicated to actually building the SQL. It validates the syntax. It actually tries to do a dry run. And then we actually have something that reports and tries to visualize the data afterwards. And this is okay. It was quite expensive because it uses the same sort of overall context in across 3 separate LLM generations that go over many, many turns. And then we tried to condense them all into one agent. So as context windows got bigger, we tried to sort of do the phases internally to the agent running. So you can see here, it's sort of the same structure where we sort of have the same phases. We have the planning phase, the building phase, the reporting phase. But instead, all of the different context, what it pulls from the file system, what it gets from Snowflake, is all managed in the same thread. And so this was better, of course. Models get better, AI gets better, building agents gets better. But eventually we sort of just hit like a roadblock. And we thought, what if Claude Code was just good enough to do all this? And so we actually just threw away all the code, all 20,000, 40,000 lines of code that me and the VP of data wrote. And we literally just embedded Claude Code SDK into the root handler we had for this agent. And it was actually pretty good. You know, we just literally used the Claude Agent SDK. We asked it the query, we gave it access to executing Snowflake. Ignore the other tools here. It could always read the semantic layer, and it could also execute and visualize the data. And this was amazing. This was like the first unlock that we felt comfortable shipping D0 to a few other members of the Vercel team. And after seeing this success, we were like, oh my God, like, isn't the big unlock the file system? And so then we came to a conclusion that all you really need is the file system. And that like Claude Code, it's just so good because it doesn't have all these like random phases, random tools, random sort of human constructs. It literally just reads over files, greps around to find the right fields, and it's just smart enough to figure out what it needs to do. And so that's what we did. So like between the Claude Code version and this version, we actually published a series of packages related to building better file system agents. We published this thing called Just Bash. It's a TypeScript reimplementation of Bash that's quicker to start up and is more safe than being able to execute arbitrary commands. We built this thing called Bash Tool. It's an AI SDK compatible drop-in tool. You can see it being used here that composes either a virtual Just Bash environment or a sandbox to execute any of these Bash commands in. And we also let you take in some amount of files to initialize, or you can push files to it later. And so if you look at this structure of code, we have a sandbox. We create a Bash tool that executes inside the sandbox. We have the semantic layer. You can imagine that as just a bunch of YAML, JSON, markdown documents that cover everything from our tables to why things happen, to example queries, to sample values. And then you can see we have the familiar generate text call that goes to the latest state-of-the-art model. And this was actually so good. This was everything we wanted, but trimmed down to be just what we needed and still just as good as what we had before. And so after this, we actually launched it to the whole company. All 600 people started blasting D0 with queries from everything from financial metrics to product metrics to team metrics to even like projections and how they could use what Vercel has to better serve a customer? Like, is customer X using all of Vercel to its best potential? Why did this surge in bill happen? Stuff like that. So everyone was able to now have the sophistication of our VP of data without having to bother the VP of data to stop what he's doing and to write some random basic SQL query. And I even wrote a pretty good blog post about it. Don't mean to brag, but for the week that I wrote this, 53% of page views to Vercel.com went to this blog post. Would recommend reading it. It sort of details sort of this exact flow of things and also how our data science agent was so successful after the fact. And that leads to where we are sort of today. So I mean, the most optimal way to write an agent or build an agent has changed many times. You know, the time in which we built the file system agent, we didn't have skills yet. And so a lot of the ways of, you know, what does it mean to aggregate across product metrics? What does it mean to estimate why a customer will go over their spend? What does it mean to figure out why a metric is successful or not? You know, all of those are sort of ingrained into the system prompt, but in reality, they're mostly just skills, and they're more so different ways to find the right data and also structure the right query and then report on it based on the type of questions being asked. And so we actually took what we had with the file system and we broke it down even more granularly, and we have this create skill tool. You can see it's exported from Bash tool that does a similar implementation to what Claude Code does in terms of reading from the file system, loading the skill in, executing the scripts as part of the skill. And this is currently the best way that currently serves 12,000 queries a day from people across Vercel. You know, we have automated jobs doing reporting. We have people trying to get better customer insights. This D0 agent has really set the initial bar for everyone at Vercel building agents across the company. And so that leads to where we are going. You know, right now we have this D0 version that uses skills, that uses the file system. But, you know, everyone at Vercel is trying to build the same experience for a different use case. You know, we have legal 0, we have PM 0, we have sales 1. You know, we have a bunch of these agents that are trying to mimic the sort of UX and success and accuracy of D0, but they end up having to sort of go through the same phases that we just went through. You know, they build some basic version, they iterate on it, new practices come out. There's not really a best way to make it from 0 to 100 right now. And so that's why we're actually investing time right now to build sort of like a Next.js API for building agents. So you can imagine a file system where you drop in skills, you drop in context, you drop in memories. It can sort of self-modify to make itself better. And it's fully serverless, which means it can scale and it could work just like any other application on Vercel. And this is highly experimental, but you're the first to hear. So if you're interested, we'd love to give you a sneak preview or see what you think. If you're building agents, if you've built an agent before, or if you're just agent curious. And that's all I have.
Hi, I'm curious about that statement, an agent at every desk, because in my experience, it's many agents at every desk. I'm curious what your and Vercel's vision is in terms of what that scale looks like internally, like how should we be thinking of scaling agents internally in an enterprise?
Good question. I don't think there's a solved answer. I think it's evergreen on how best agents can be in the workforce. You know, for us, every manual process that we've ever had, from transcribing a sales call once over, to doing a retro on the marketing campaign, to redlining contracts even as they come in, you know, all those at least have some point of contact that's trying to make it more automated. And these are tools and these are tasks that we could never do before without AI. You know, they're a little bit more subjective, they're a little bit more dynamic. And so it wasn't really something that we could just automate away before agents existed, before AI existed. And so to that, I think, you know, there's always something that's boring about your job that could be more exciting, that is sort of repetitive, that I think if you really dig deep, you can sort of figure out what that is and what agent can solve that problem.
Also, I was curious about V0 usage for internal versus external use cases, because it seems like you probably have consumers and enterprises looking at your products.
For D0 or V0?
V0.
V0.
Yeah. How do you think about that, or how do you approach that internally?
You're just asking about usage for V0 inside and outside of Vercel, right?
No, like the people who are buying V0 or like looking at V0, Do you see it more as like a consumer thing or like a enterprise thing?
It's both. So also, once again, we're talking about V, like Valentine.
Yes.
Okay, yeah. Yeah, V0, we have probably the most diverse use case in the world. You know, we have the single indie hackers, hobbyists, all the way through galactic enterprises. I'm trying to think of a logo I can share. I'm not sure, so I'm not going to include those for now. But we do have enterprise use cases where they sort of use V0 as the central source of truth to get any idea out there. These are mostly companies that just want to move faster. And so they could start with, you know, vibe coding locally and then have like localhost 3000 open. But they would rather go to V0 and do the same thing, but instantly have a shareable URL deployed to Vercel. And so we see both use cases where people are trying to build new businesses on V0 from like ground zero, one person people. Or we have like enterprises trying to share ideas a little bit more freely and have like you can almost call V0 a file system of ideas where people have generations, they share with the team, that shows up in the common sidebar. It can sort of iterate from there.
Cool. Thank you.
How do you think about being able to create things that actually provide value to users, given that these foundational models that you're building on top of are starting to get so much better so quickly?
Good question. I mean, it's so you're saying like, assuming that we don't do any of this, that everything will be solved already by the big labs because the models will be so generally good. Yeah. Yeah, it's a good question. I do think that there is, I mean, if you look at the usage of Claude Code, people use it for everything, right? From writing docs to doing reporting to even doing marketing campaigns and creative things. So in a way, you're right that the models are already so sophisticated that you can pretty much do everything with the current generation of state-of-the-art. But I think there's more and more novel use cases that require a little bit more creativity, some more connections, some more sort of bespoke knowledge to make it work. So I mean, like, of course, right now, Claude Code could one-shot some Next.js app that has authentication and login. But if you ask it to go a little deeper, to actually build, you know, something that solves a real problem or has payments or has the right sort of field to get people through the funnel, I think that will always be evolving. And, you know, eventually be easier and easier, but there will always be new ways to do things that, you know, makes people more efficient or slightly different from what the model's really good at right now. And so I think it's an ever-evolving problem, unless you have AGI, in which case then it'll auto-evolve and it'll automatically learn all these things by itself.
So you mentioned that towards like the end of your exploration, like basically you kind of converge on file systems becoming like super important. I have a couple of questions around that. First is like, how do you maintain the synchronization of like your file system with like, let's just say all the data that you have in your org? Like if you're doing sales, PMing, whatever, like do you synchronize, for example, I don't know if you guys use Notion internally, but like Notion to your file system or like, let's just say like Snowflake, like do you somehow synchronize that? God forbid, do you have like an NFS drive somewhere that's like global Vercel state or something?
For sure. So it's not as stateful as you may think. So when you actually look at this code snippet right here, this semantic layer is actually like a fetch request to a blob store or to another endpoint that dumps the whole current Snowflake schema into memory. And so when I say file system, I mean like we spin up an ephemeral sandbox. We dump all the latest files from Snowflake, from all the bespoke processes that the data team has written. And so it's always being updated. So I mean, like we've seen D0 fail for certain cases. Like maybe we are querying for AI SDK package downloads, and we just don't have that yet. So then in the subsequent day, we would add that metric. And then next time that someone asks for the same thing, we will then be able to pull in the updated context, the updated schema on how to pull that AI SDK download data. So in a way, this file system isn't really a living file system. Like I cannot just like go in and like click on this file. It's ever changing. And every time an agent runs, that's when we populate the file system with the latest stuff we have.
As a follow-up, like do you see a universe or for example, like, yeah, like, you know, we use Notion a lot as Stainless. Do you see a universe where Notion is just like somehow accessible through like your file system, you know, like let's just say MacFuse or, you know, some user system like file.
I would love to see it. I don't think we have the best Notion hygiene. I think a lot of pages go stale, a lot of pages backlink to deleted pages even. And so if you're really up to date with how you document things, for sure. But for us, our source of truth is Snowflake. And so when we know that we add new fields, more tags, more sample values, and when we update the schema to tag every cardinal value, we know that that is the ground source of truth, and we'll always pull from Snowflake and or some other data pipeline that we always keep up to date, because that's where we query data from.
Gotcha. Thank you.
Super cool what you guys are building at V0. And I was wondering, because I talked to you, I've talked to other framework providers for agents around how do we make it a super easy experience for people to create agents, but then also take them all the way to production? And how do we give users everything that they need to be able to do that? Maybe it's sandboxes to make agents more performant. Maybe it's certain LLM guardrails to make sure security is at play. And so when you're launching these agents into production and you're choosing which files are going to be mounted into that sandbox, I'm just thinking, how are you thinking about holistically, where does the security boundary lie between your responsibility and the users? Is V0 secure by design, build an agent there and you are good on security, or does the user have some ownership of that? And how do you think about that separation?
Many answers to this. So definitely the users should be well informed about the best security. But in the meantime, we try our best to handhold our users to going down the path of success. So a few things are, this sandbox.create is actually fully firewalled around it at the control plane level. And so any outbound request, if you specify an extra param, you can specify a bunch of whitelisted hosts that can make requests too. And so you can say you only want to make requests to OpenAI.com and GitHub.com for cloning and inference. That anything that tries to exfiltrate to something else will get blocked at the Vercel layer. The second thing is when it comes to secrets. So actually, if you were to run a coding agent in a sandbox, which you could, but you maybe shouldn't, you should do something like this, where you can think of the control plane accessing the sandbox, but it's not actually running inside the sandbox. You can actually inject the secrets into the agent runtime in the sandbox. So we have this feature that lets the agent be unaware that it's running in a sandbox with certain credentials, but when it actually runs, it'll go through fine because it'll proxy the request to a server that does have the credentials. And so we try to build in these security features built in. So as you're building on V0, as you're building the next D0, you don't have to worry about anything malicious happening or anything bad happening, but it's still good to know where the bounds are and what you really should do or not do.
Awesome, thank you.
All right, we have one final demo left, and that will be from Ian from Keycard.
Thank you, everyone.
Oh, look at that. I remember how to use these things. How's everyone doing? Great. My name's Ian. I'm the co-founder, CEO of this company called Keycard. And that's not full screen, so let's figure out how we do that. So, there we go. It's beautiful. All right, as I said, my name's Ian, co-founder and CEO of this company called Keycard. We're working on agent identity and access. I think we all can tell that we're going from a shift, right? Computing was designed for this role where humans were pointing and clicking on interfaces or typing commands in CLI tools or writing all the code themselves, to this world where we're quickly giving these agents some intent. They're interpreting our intent and doing our job for us. That's a little hyperbole, but it's not far from the truth. And the fundamental problem that we have, and show you what we're working on with Keycard, is the identity systems underlying everything that we do, which is the fundamental building block of all security systems. They assume a human is somehow in the loop or a workload somehow in the loop, and agents are neither of those things. In fact, agents operate on our behalf. They are not us, and they're not a workload either, in the sense that they don't do the same thing bound over and over and over again. In fact, with an agent, you want an agent to be able to discover a broad depth of functionality. But when you say, hey, can you go do this task for me? Maybe go figure out the best pair of jeans or whatever it is. You don't want it to, randomly spend $500. You want to spend $50 at most on your favorite pair of jeans, or better for worse, you probably don't want your agent to be able to, drop the database when all you want it to do is read a specific table, right? These are some things that sometimes happen if you give the wrong prompt. And more importantly, your friends in security and the people that say yes to things, especially if you're at a larger company, they don't really have any view or ability to understand what agents are doing. And certainly I don't know what my agents are doing on my behalf when I'm not looking at the screen. And the function of this is like we basically have this choice as users, right, or builders. You have a choice between ensuring like basically locking agents down and not letting them do very much. You can let them run and you kind of lose all this visibility control. You're trying to build some intermediate thing yourself. At the end of the day, where most people end up here is we end up with that yes, no, always allow, approve dialogue thing. I'm sure we all seen the meme, which is basically just killing our agents' capability, their autonomy, and truly our ability to actually realize autonomous agents through consent fatigue, right? Security theater, it's worse than the TSA. So the final challenge is like, how do we give these agents autonomy? These things are inherently non-deterministic, while also having some level of deterministic control over what they can do to prevent really bad things from happening. And I'm sure we all have been on the Twitter in the last week, but what a week in security it's been. First of all, Merkur got completely and utterly breached with all of their data and everything walking out the door. That really sucks. Unfortunate. We had the LLM PyPy supply chain attack, and of course, we had the Axios attack as well. At the core, all these attacks, yes, they start with the supply chain, but what are they actually? They're a credential exfiltration problem, right? We all have API keys, AWS creds, database credentials, everything sitting on disks. If you open up your Kubes cluster, they're there. And so the minute that one of these supply chain attacks get into your system, you're pretty much and utterly screwed, right? And once they've left your system, there's nothing that stops, any nefarious actors from taking those and, walking away with all of the data and all the value of your company. And I really do feel for those founders. That's quite unfortunate. So the question is like, what the fuck do we do, right? Like, we have this like very broad problem where as a developer, you go to any dashboard, you copy an API key, you drop in .env file, and you're off the way to go. But unfortunately, the inherent thing is that this doesn't really work for us, right, in this new era. We have to move to a world where things actually are done by a delegation, right? So a good example is that an agent, like a Claude Code or something you build, it should have a base set of things it can do on its own behalf for a specific task, and what it can do changes dependent upon the task you assign it. But also, we want to ensure that agents only operate in a delegated way. So if I, as a user, say, hey, agent, can you go check my Snowflake and see, what's changed in the last couple of days, it can only does what that user is able to access, what the users wanted that thing to access, and it can actually read that, and we can ensure it's on the device. But more importantly, what we need from that is like these agents have concrete identities, right? So we can't move to a world with delegated access. We can't solve the credential stuffing problem that I mentioned if we don't actually move to a world of highly ephemeral credentials. We can't move to a world of highly ephemeral credentials if we don't actually know who these different identities are, and on and on and on it goes. And most importantly, what we need underneath the hood is to move to a world where you actually have the ability to revoke what an agent can access at any point in time, right? Like today, we all know the plague of static API keys. You go dump a bunch of them in your .env file, you deploy them to a bunch of different places, and now, holy shit, what do you do, right? Rotating that sucks, and they walk away. And so at the core, what we actually need to do is be able to move not only from static API keys that are all over the place, we actually need to be able to bootstrap the identity of systems based on the place where they're running, right? And we need to ensure that when those systems bootstrap and start up and they start talking to our systems, we use proof of possession to know, hey, it's this thing running on this device. So it's this Claude Code running on this sandbox as an example. And as a result of that, we know it's allowed to access these systems, and there's two pieces of data that come together to ensure that thing can actually get access. So that's a lot of silliness to talk about, but let's talk about how do we actually get there, right? Like one of the hardest parts in identity and access security, and let's talk about protocol change, is like, how do we actually get going off the world? And so one of the things we're working on Keycard is enabling people to build really simple tools, whether that's an MCP server, a CLI tool, whatever, and a website where you can drop in and get this ability to do ephemeral credentials that have high trust baked in. I have a drop-in SDK, and so this is what this is. So what you're able to do is put something in front of, let's say, Google, your Snowflake instance, build some servers you built yourself, you add our SDK, and now the interaction between the agent and the MCP server is that of high trust. It uses ephemeral credential, it doesn't live on disk, it's tied to the device, but more importantly, it includes delegation information. So it's user X using the agent X operating on behalf of user X, and that becomes a part of your authentication authorization statement. And so as a result of that, the agent actually never has access to secrets. There's actually no proxy here involved. There's just a identity infrastructure under the hood, but you can bridge from your agents to these like long-lived these systems. And so one of the things that I was going to show tonight is, okay, great, that's a lot of talking about some very boring subjects that none of us had to really think about for the last 10 years. We have to think about again is, okay, how do we actually give agents access to Gmail without these overscoping? And so I've got a demo here of code mode. We dropped in our Keycard SDK. For those who are unfamiliar with code mode, it's something that Anthropic and Cloudflare and actually Stainless as well have been talking a lot about as a mechanism for enabling us to, basically bridge agentic access to systems, but also solving like tool bloat problems and other issues. But ultimately what we have is a sort of open API schema on the left-hand side. You could have it be any schema, it doesn't really matter. You generate an MCP that gets deployed someplace. Inside MCP basically gets two tools, right? It gets the ability to search. So, hey, I'm an agent, I'm trying to do something. What can I use under the hood to do that thing? And you get the ability to execute. And so, the agent can, look at the tools that are available, say, hey, this is the sequence of things I want to execute, and those things are executed inside this sandbox. And the most important component of this is that inside that sandbox, the thing that's executing at no point is actually have real credentials. All the credentials are replaced, kind of like the V0 proxy that our friend was talking about. And all the interaction is between like the main worker and this sort of Gmail API. And that main worker only has this attenuated scopes of access that user would ever have to Gmail. So for example, if that user said, hey, you can read anything in my inbox, that agent would only ever be able to read things in their inbox. There's no overscope credentials. You don't have this issue where it could walk off. And more importantly, that agent doesn't actually have a real credential that gives broad-based access to the system. So let's go look at a demo. It is sharing my entire screen, but it's not sharing my entire desktop. So let's fix that really quickly. All right, so we're gonna pop ourselves over here into, that is absolutely way too bright for anyone on a. There we go. Excellent, so much better. Okay, so inside Keycard, you have concept of applications. In this case, we have sort of this Gmail, Google application that I mentioned. In Keycard, you build apps. Apps have resources. In this case, this app has access to Google Calendar APIs, the Gmail has access to Google Drive. And I'm going to go and install that into Cursor, which is my current coding harness friend of choice. And I'm going to click the install button. And then I'm going to switch windows really quickly just so that we actually get the right thing. And so you'll see that I've been prompted by our friend, we've all been here, to connect Google, to connect to this MCP server. I'm going to click connect. It's going to pop me over to Google, send me back to Cursor, and now I should be able to talk with our little friend and say, hey, what emails are available in my inbox? And so without me having to build anything, I was able to take this open API spec. I pushed it up to Cloudflare earlier today, just as it's too boring to have you guys watch the deploy screen. And now this agent is Cursor is capable of interacting on my behalf with Gmail. It's only ever scoped to exactly what my user ever has access to. I can go and revoke that in the dashboard, but more importantly, I can go to Keycard and I can look inside our session log and see exactly everything that agent is currently doing on my behalf in real time. And so some refreshes real time. And if I wanted to, I could go and revoke its access, and it'll all get revoked immediately. So there's nothing left over. It's end to end. And so to build this, it's a very simple drop-in SDK. I can show you the snippet, but our friend Cursor should be done now. It's still going. This is one of the downsides of code mode. It's something that Anthropic's a really great blog post on how to sort of fix this with like skills and stuff inside the box. But eventually you'll finish. You looked at all the tools, it'll run the code, and they'll say, okay, here's what you've done. And at no point did the agent actually have real credentials. At no point did the agent have more access than it should have. And at no point were those credentials ever available or on disk. And this is all tied and plumbed through. So when OAuth to me, to the system, and Keycard's sitting in the middle, but it's not actually interacting with any of the data. So that'll finish, but I'm happy to take questions while we wait. Well,
I'm just curious, how did you just come up with this idea? Like with other cool ability in space, but you did that user tool, then also you want to get
yeah, so this is a really good question. This question was like, well, why do you think you can win effectively? That's a really good question. So I think there's a couple things. One is every generation, this is my third company. So like every generation we've gone from like mainframe to personal computers to the internet to the cloud to mobile. Now let's say we're in this agent thing. Every iteration has required like basically a shift in security landscape. And, in the mainframe to multi-user computers, we had to introduce like user systems, right? That's what, the user groups and stuff inside of Unix are for. When we went from, just personal computers to the internet, we had to go invent TLS. We had to go invent things like, the browser sandboxing model, and there was lots of stuff that had to be done there. When we went from the browser sandboxing model to the cloud, guess what? We got Auth0, we got Okta, but we also already had LDAP, Active Directory, and everything else. And so every iteration that we go through these platform shifts introduces a whole bunch of new identity problems that didn't exist previously, and they're always different than what came before, and agents are no different. And so Keycard's position is that agents require like a fully different model. Most identity solutions in the space only solve authentication. They don't solve authorization. They also don't enable you to do actual delegated access. And that's a different architectural shift than what came before. That's a very long way to answer to say, our bet is that they're architecturally screwed and we can build a better thing. That's simpler to use. That gives you the primitives everyone's looking for. Yeah. Cool.
So I'm not a cybersecurity expert by any means, but I have been following the light LLM supply chain attack very closely this week. And what you've built is super cool. I would love to hear how you think Keycard could have helped mitigate some of the light LLM, getting pwned and stuff.
Yeah, it's a really good question. I think minimally at the forefront with Keycard, no credential. So we have a utility called Keycard Run effectively, but ultimately, with LightLM, the biggest issue is that you had this thing that got installed, but I think it was a pre-install hook, right? Like when you download from NPM and execute it. Well, the biggest issue there is you just had credentials sitting on disk in the same user space as the execution. And so from Keycard's perspective, the first and most simplest thing is like just don't have credentials sitting on disk. That reduces like the first burden. So any credentials that do exist only ever live in memory, and they're highly ephemeral. So they're not actually like sitting there on disk. Now, the second component is moving from that works because we're not statically binding anything. We're actually bootstrapping, like we're testing to the device. So in my case, it's my laptop. We're testing to the laptop and saying, hey, this is Ian's laptop. And we can do that because there's there's a T, right? In every laptop, on a mobile phone, there's a trust store that has like root signing keys. And so because if we can attest to those root signing keys, we can say, oh, it's Ian's laptop. And then because we know it's registered to Ian, we can say a lot of different things. And as a result of that, we don't have to have like long-lived keys that are sitting around on disk to prove the identity of any one thing. And so that removes 90% of the supply chain attack. And then the second component is, as you move towards proof of possession tokens, which is basically like, hey, I have an access token, but then in order to use the access token, you need another key and you have to basically sign the access token. That on a per call basis, there's some mechanics there. The downstream authorizer that's looking at that access key that says, hey, is this like true, good, or bad? And sit back and say, oh, well, you might have walked away with the access token or whatever secret value it is, but you aren't running it on a device we trust, and thus you can't use it. And so those two things together move us to a world where things like LightLM don't. Yes, those attacks can happen, and the supply chain attacks are not going to go anywhere. It's like a very, very difficult problem. But minimally, like they'll go from absolutely devastating to okay, bad, but like we're gonna be okay. Yeah.
Related to what you were saying about a lot of things not being built for agents, that applies to standards like OAuth and like a lot of foundational things. I know it is a cybersecurity space, we're like building on top of those in terms of authorization, things like that. But do you think there is an imminent future where we move away from OAuth and other standards?
No, I mean, our main bet is that OAuth is here to stay, right? And like minimally, like OAuth gives us basically the basic flows you need. The thing that's missing is a bunch of extensions on top of OAuth to bring like workload identity and device identity and like fine-grained like resource targeting together into a way that like people can commonly implement and understand it. And so our view is we've been on sort of as a industry, we've been on a march towards consolidation of security controls at the application layer, right? Like if we think back to 2005, like the thing that mattered was basically like your firewall, right? Firewall rules, TLS, firewall rules, and cookies were basically the three primitives we had to build systems with. And increasingly, those primitives are not sufficient in a world of agents, because agents operate with local tools, remote tools, across boundaries, internally, externally. And so our view is like all of those access controllers moving up, and OAuth is probably going to be, because it's so widely adopted today, and so many people have actually built an implementation, it's what's going to be built on. The challenge isn't so much the OAuth token flows, it's actually how do you have the representative data model that lets you represent all these interactions.
I have a more granular question. So if I was utilizing Keycard, and is this the agent holding in more like a session, a task, like how would it hold like the communication with certification authority, or if I was wanting to use it multiple times, like how does that work?
Yeah, absolutely. So with Keycard, all agents get like a hardened identity. Actually, it gets like what we build on top of ConID metadata documents for OAuth 2.1. So every agent gets like a public identity, and that's baked in from the start with when you use Keycard for building an agent or a tool, and that's where the core building block. And then what's the second part of your question?
Like the interaction with like the certification authority, like authentication aspect.
Absolutely. So from that regard, like we're doing the key management layer for you, right? The minute you have any type of like PKI infrastructure, you get into this cacophony of like, what the hell do I do here? Like, how do I manage these roots of trust? How do I establish who's trusted? How do I then do that in a fast and quick way? And so we give that to you out of the box. And so what you don't see from that SDK is all the things I just mentioned, right? Like all this stuff's under the hood and hidden from you. It's available and you can kind of dig into it and understand it. The SDKs are open source, but like our goal is to give it to developers like these simple building blocks required, while also enabling and we had someone from Google present multi-agent architectures, but like how do you actually have a highly ephemeral multi-agent architecture where things are delegated from one session to the other, so that in an instance where you have, the Dungeons and Dragons demo, each of those agents has their own identity, and the shopkeeper, if only has the ability to like spend money on behalf of the user, but not any user, as an example.
Thank you.
Cool.